channel, we are looking at integration of rational function by partial fractions. In this episode, I'm going to show you how to integrate a rational function by expressing it as a sum of simple fractions. What do I mean by rational functions? I mean a ratio of fractions, a ratio of polynomial. And in these ratios of polynomial, several things will happen. We're going to look at different cases. We're going to look at case 1, when the degree of the numerator is greater than denominator. We are going to look at case 2, where we have a product of linear factor at the denominator. We are going to look at also where we are going to have an irreducible quadratic factor at the denominator. We are going to also look at a repeated irreducible quadratic factor. Okay, let's dive in straight away and see those different cases. Case 1, let f of x be equal to p of x over q of x. That is the rational functions. Whereby case 1 we want to look into, in this case now, is the degree of p of x is greater or equal to the degree of q of x, I mean denominator. This calls for polynomial long division. So without wasting time, this is the case study for that case 1, whereby the degree of the numerator, which is p of x, is greater than what? Than the q of x, than the denominator. And this calls for what? Applications of what? Polynomial long division. So, and that will be equal to, the denominator will be outside, x minus 1. The numerator is a polynomial, it's starting with power 3. So the next one will be what? 0x squared. There's no x squared here. And then plus power 1, x to power 1. And then we expect to have a cosines, that's 0. So the first thing you do is to take this first item, s cubed, over the first one here, over x. And that will give us what? X squared. That will come here. And then use it to multiply what you have here. S squared times this, that's s cubed. S squared times minus 1. Then you have what? Minus s squared. Then after that, in subtraction, this minus this, giving you 0. 0 minus s squared. That's giving you what? Plus s squared. Then the next value, you bring it down. Because this is x, there's nothing here, minus what? 0. So we have what? We have plus x. Then repeat the process also. Take the first one here, s squared, over the first item here. So that will give us what? Plus x. Use it also to multiply this place. So x times x, that's s squared. And then x times minus 1, that's minus x. Then you can do your subtraction. Then you have this one minus this one, 0. This one minus this one, that's what? That's a plus 2x. Plus x minus x, that's a plus 2x. Then the next constant to bring it down, that's what? Plus 0. Repeat the process also. You have 2x. Also divide by what? By your x here. Okay, so that's giving you what? Plus what? Plus 2. So 2 times this, that's a 2x. And then 2 times minus 1, that's a minus 2. Okay, do your subtraction again. If you do that, this and this becomes 0. 0 minus 2, that's what? That's a plus 2. So this is what we call the quotient. What we have here is the remainder, and this is our what? Divisor. After we've done the polynomial long division, then we can now do the integration. So the question we have, this one, is equal to, the formula will be the quotients as a function of x plus the remainder as also functions of x over the divisor. Okay, so and that will be equal to the quotient is plus the remainder is 2 all over the divisor x minus 1 dx. So we can integrate all this. Integral of s squared with respect to this function. This is power 2, so plus 1. That will be s cubed. Then you divide by this power over 3. Then plus integral of x, this will be power 1, so the power plus 1, that's x squared over 2. Integral of 2, when you integrate 2, okay, is a constant with respect to the function. We're going to have plus what? Plus 2x. And then integral of this 2 is a constant which you can take outside the integration, and that will be 1 over x minus 1 dx plus c. So on the final conclusion, we have this Integral, this one is a direct table, and that will give you ln x minus 1 plus what? Plus c. So, and that finish this question. I want to say at this point, if you are yet to subscribe to this channel, quickly smash the watermark of this video and subscribe. Click on like button, begin to type your comments, and finally share the links of this video on all your social media platforms. Share the links of this video on all your social media platforms. Thank you for doing that.